Hello friends and my dear students, as we are studying mechanical vibration, which is third year 6th semester BTECH mechanical engineering curriculum as per the Rajasthan Technical University Quota. Okay, so we have completed all the above 3 units as we have discussed before. So we are there in the unit number 4. We have discussed about the basics of the force damped vibration as well as what are the steady and transient parts and what are the frequency response curve we will see today, as well as we will move toward the vibration isolation and transmissibility. So let's get it started with the previous session where we have left. So in the last session we have discussed about the how you can calculate the phase angle, okay, with the help of this particular graph, which is equals to tan phi is equals to c omega divided by s minus m omega square. You can also rewrite this particular formula by dividing this whole denominator and numerator by omega n. Then you will get this value as 2 zeta omega divided by omega n 1 minus omega by omega n whole square. Now these are the two handwritten graphs you can see here. You can also fetch up these graphs in all the books of vibration, either it is Asst or BPC. You can go through those plots. Okay, so this is the graph or curve of magnification factor versus frequency ratio, okay, where magnification factor is amplitude divided by f naught by s. And if the value of zeta is equals to 1, then this graph will start from this point 1, means magnification factor will be 1 here, and it will direct decay like this point to this point. Okay. Similarly, as you will reduce the value of damping factor, you will go to the peak. Okay, and you will also find the asymptote values here at a point zeta equal to 0 or very negligible value or near to the 0. You will find a asymptote instead of a whole curve. Okay, so this way you can also enumerate or differentiate your conclusion on the basis of this curve. And another curve you can see here is phase angle versus omega by omega n, or ratio of natural frequency versus the frequency of vibrating system. So you can also find it out that if zeta is equals to 1, then it will go like this, and if it is reducing to 0.375, 0.15 and 0.05, and the phase angle is 0, 90 and 90, means at angle 90 it is just changing the phase plot, or you will say just reversing the phase angle. So in this way you can also see that if ratio is 1, then at a ratio 1 and 90 degree there are some kind of changes, means at a critical speed where omega is equals to omega n, means the ratio is 1, then centrifugal force is in the same direction of displacement. You can also satisfy, or you can also conclude the same thing when you will just go to those plots, like just starting with this particular curve or drawing this curve when omega is equals to omega n, or omega by omega n is less than 1, means that phi is less than 90. Then you will plot this particular term where phi is very small, and if it is equals to 1, then definitely your centrifugal forces will be in the same direction as your displacement, as you can see in this particular picture. And if it is greater than 1, then this will look like this, means if phi is less than 180 and greater than 90. So in this way you can also draw this particular free body diagrams of these different forces, which we have also studied in this particular last session, that how you can derive these particular curves. Okay, you can also go through it. Now let's see that what do you understand by the vibration isolation. Basically, in order to diminish or reduce the transmission of forces to the foundation, or I will say just reduce the vibration or vibrating forces to the foundation of any machine, are mounted on the springs and dampers as shown. Okay, means you can clearly see some kind of vibration isolators are attached at the bottom side of different kind of diesel generators, which you can find it out at various malls, various big institutions. You will find out that we have to create such kind of base at the bottom of any kind of DG sets where there are huge vibration. So that is an example where you are using some vibration isolation, or some isolation pads you use where such kind of machines are involved. In heavy industries where some rotating or some machines which are having some vibrations, there you have to use such kind of vibration isolation system, or at the bottom side of that particular machine. So same thing, what you can do, you can mount it on springs or dampers, as you can see here in the picture. This FT is transferred to the foundation, and your task is to remove this particular or reduce this particular force transmitted to the foundation. Okay, and that's why this Ft, force transmitted to the foundation, and this Fo is force applied, external force. So ratio of these two will be called as transmissibility. Okay, and similarly you can also draw this particular curve, and you can see that if ratio is equals to 0, then it is good, and as per the real condition, this transmissibility ratio is either tends from 0 to 1. So this epsilon or transmissibility ratio Ft by F naught will be equals to Ft divided by F naught. The value of F naught is this particular formula. Okay, so and this epsilon, or I will say transmissibility, will depends on omega by omega n and zeta. Okay, and omega by omega n is equal to 1, then epsilon will be 1. If it is root 2, then epsilon will be 1. So at these two conditions, this transmissibility ratio will be 1, means your foundation, whatever force transmitted to the vibration is equals to the applied force. Okay, similarly you can also enumerate these conclusions with the help of these graphs of transmissibility versus omega by omega n, and also fetch up it from the books. So this is the transmissibility formula, which is epsilon is equals to Ft by F naught. This way you can also calculate it with the help of this particular formula, and most of the time they used to recall or ask in many objective questions either in GATE and IES that when transmissibility factor is equals to 1. So you can also say omega by omega n should be equals to root 2. Okay, so Ft is equals to, say, under root 1 plus 2 zeta omega by omega n square, and similarly F naught is this particular value. Okay, and this epsilon depends on these two values as we have discussed. Now the vibration will be effective if epsilon is less than 1, or omega by omega n should be greater than root 2. Omega is less than omega by root 2. That's why. And if omega by omega n is less than root 2, then there is very less damping there. Okay, but if it is omega by omega n is equals to root 2, then damping is required, because epsilon is means same force is going to be transferred to the foundation, means you have to provide some kind of damping at the bottom side of that particular machine. If it is less than root 2, then definitely additional damping is required, means very high level of damping is required in case of transmissibility factor is greater than 1 or Ft is greater than F naught. No damping means damping is not required, means if there is no damping is provided, then zeta means damping factor will be equals to 0. Then your transmissibility factor or transmissibility will be equals to 1 divided by modulus 1 minus omega by omega n whole square. So in this way you can also calculate such kind of small objectives which are going to be asked in competitive exams or any kind of other exams. Okay, so in this way you can also recall this particular topic. If you have any kind of doubt, do comment in the video comment box. If you have any other kind of queries, feel free to contact faculty or faculties. As in Engineering College Banswara, you can contact me. Thank you so much for your patience hearing. If you have not subscribed this particular channel of Engineering College Banswara, do subscribe. If you like this content, hit the like button, and stay tuned with Engineering College Banswara YouTube channel for more such updates about different branches of engineering like mechanical, civil, electrical and computer science engineering. Thank you so much, and do visit this channel regularly if you are really enthusiastic about knowing different domain knowledge about various engineering branches. Okay, thank you so much for your patience here.